Normal distribution in Excel. In this video, we are going to learn how to construct the normal curve in Excel. But before that, let's have a brief introduction to this distribution. The normal distribution is a continuous distribution defined by this formula where mu represents the mean and sigma square represents the variance and the sigma is the standard deviation. In this case, the range of x is from minus infinity to infinity. This mathematical equation depends upon two parameters. One is mean, that is a mu, and another is a sigma, that is a standard deviation. So therefore, in some literature, you will find such type of notations where mu is a mean and the sigma is a standard deviation. The normal distribution graph forms a well-shaped curve called as a normal curve, and because of this, sometimes the normal distribution is also called as a bell-shaped curve distribution. It is also referred as Gaussian distribution. There are certain properties of the normal distribution. Firstly and importantly, the area under the normal curve is 1, means if you take the integration from minus infinity to infinity of the function fx, in that case you will get as a 1. Secondly, this curve is symmetric about the vertical axis through mean, which further gives you another result, that is the area to the left of the mean is equal to the area to the right of the mean, which is further is equal to 0.5. It means the area under this curve towards the left hand side, this is equal to 0.5, and the area towards the right side of the mean, that is also is equal to 0.5. Moreover, in the normal distribution, the parameters mean, median and mode all are equal. Now we are going to find the normal curve for the data of 1736 students of their CGPA, but this data is in form of discrete. So in that case, we can apply the binomial distribution. Now why we are not moving towards the binomial distribution? Because the size of this data is greater than 30. Therefore, we are switching towards the normal distribution. Since data is in a discrete form, so very first we will approximate that data in the interval form. So now how to approximate that data in form of intervals? So first we will take the histogram of the binomial distribution where n represents the number of trials and the p represents the probability of a success. After that, we will superimpose the normal curve with the same mean and variance as the binomial variable have. So in case of binomial variable, the mean is equal to n into p and the variance is equal to npq. So by using this data, we will find the mean and the variance, and after that we will find the normal curve. For example, in this case, the histogram representation corresponding to the binomial variable with the number of trial as a 15 and the probability of getting success is 0.4, where this curve is basically a normal distribution with the same mean and variance as this binomial variable has. That is n into p as a mean and the variance is equal to npq. Now suppose that if you want to find the probability at x is equal to 4 using the normal approximation. What does it mean? It means we need to find the area under this curve. Means we need to find the area of this rectangular region, and this normal curve is between the point 3.5 to 4.5. Because the length of this rectangle is 1, so we are taking a 0.5 towards this one and the 0.5 towards this one. Means if you want to find the probability at x is equal to 4, so this probability is approximately is equal to probability from minus 3.5 to 4.5. So when x lies between 3.5 to 4.5, means we are calculating the area under this curve. So this area can be calculated as this area minus This area is calculated as probability when x is less than or equal to 4.5, and in this case that is calculated as a probability when x is less than or equal to 3.5, because this point is a 3.5 and this is a 3. By subtracting this value from this one, in that case you will get the area under this curve. It means this value is equal to probability x less than or equal to 4.5 minus probability x less than or equal to 3.5. We need to calculate at x is equal to 4. So how you can represent this in terms of 4? So we can write this as is equal to probability x less than or equal to 4 plus 0.5 minus probability x less than or equal to 4 minus 0.5. With this you can observe that now we need the cumulative distribution function in the normal distribution, where in this case x is considered as a discrete random variable and in these cases x is a normal variate. So we are finding the approximate value for x is equal to 4 with the help of normal distribution. The same concept we are going to follow in the Excel. Moving towards the Excel, so in this we have considered the CGPA data of 736 students. In the first step, we will extract the unique values of CGPA so that we can find the normal approximation using interval. So for that, first we will copy this data into the second column. So click on this one, then click right, then select copy. After this, click on a second column, suppose B, and then click right and then paste. So once the data is pasted, now click on the second column, navigate to the data, then click on this icon to remove the duplicate. Once you do that, you will get a warning. After that, continue with the current selection and press remove duplicate and then press OK. So with this, you will get the unique values in column B. So now we will create an interval to find the normal distribution, because for the particular value, the probability in the continuous random variable is 0. So for that, first we will observe the maximum and the minimum data from this second column. For that, sort this column. So again, click on this B column, navigate to the home, then go to the editing part, click on sort and filter, then click on sort from smallest to largest. Again, go with the continue with the current selection and then press sort. Once you do that, you will get the sorted numbers starting from the 0 to till the maximum CGPA, that is the 9.8 obtained in this data. But in general, we are considering the maximum CGPA as the 10. Also rename this cell. This is your possible values of random variable. So now we are going to define the intervals for the normal distribution. So in this case, I am considering the intervals with the step size of 0.5. So first I am starting from the 2 because the minimum value is 2. Then the next point I want as a 2.5, then 3, 3.5 and so on till 10. So one procedure is that you can write this data manually. Otherwise, you can select C2 cell, then press Shift, select C3, C4, C5. Move your cursor to the bottom right corner until it turns into the plus. Then drag this till the time you are not getting the answer as a 10 in the entry. So you can observe from the right side. Now I can lift my finger from the mouse to get these entries. Once you do that, you will get the end points of the intervals. Now we are going to analyze this data. So for that, move to the data tab, then move to the data analysis. If this tab is not visible in your Excel, then you can follow the link given in the description how to add the data analysis toolkit. Then press on this one and then press on the histogram, press OK. So once you do that, you need to add three inputs. The first is an input range. So we have the data in the column A. So click on this one. So we need to put the range of the data from the column A. So press on A2 and after that press shift plus control plus down key. So it automatically take all the data given in a column A. So there is no need to write in a manual procedure. Next we need the min range. So min means it is the number that represents the interval into which you want to group the data. So we need the intervals in form of this that is given in a column C. So for that click on this one and then click on C2. Then again use the same shortcut key to select the data, that is a shift plus control plus down key. Now we need to write the output range. So we need to select a column in which we need the output. So for that, click on this one and then you can select any empty cell from here. Suppose I am selecting a D1 and then press OK. So once you do that, you will get a two column. One is called as a bin and another is called as a frequency. So what does it mean? Suppose we want to understand what this 11 represents. So it represents that there are 11 students whose CGPA lies between 3.5 to 4. So this is the frequency of the numbers from this range. Same 126 means there are 126 students whose CGPA lies between 4.5 to 5. After that, we are going to calculate the probability. So for that, we are going to use the normal formula for the calculating the probability. That is the number of favorable cases divided by the total outcomes. So we need the total outcomes, means the total number of elements in this column A. So that can be calculated as the sum of the frequencies. When you go down, you will get one extra cell more. So we do not require this one. So you can select this one and delete this. Now we are going to calculate the sum of the frequencies. That is calculated by is equal to sum from E to the last entry in this column. So you can use shift plus control plus down key. So when you do that, it automatically gets selected all the entries in a column E. Then close this bracket and then press enter. So it gives you the sum as 1736 and that is the size of considered data. Now for the probability, that is the total number of favorable cases. So that is defined by the frequency divided by total outcome, that is given in the E20 cell. So we can calculate this as is equal to E2, that is the total number of favorable cases divided by total number of outcomes in a E20 cell. But we need to lock this one so that we can drag the same formula for calculating the probability for the rest of the possible values. For that, we will use the dollar sign to fix this cell. Then press enter. Once you do that, select the cell, move your cursor to the bottom right corner until it turns into the plus. Then you can drag this till F18. So you will get the probability corresponding to the each random variable from this interval. Next, we need to calculate the normal distribution. For the normal distribution, we need a mean and the standard deviation. So first we will calculate the mean. Mean means it is the average of the data. So for that, use the inbuilt command. So take any empty cell, suppose I2. So write the formula is equal to average open bracket, we need the average of the original data. So original data is stored in the column A from A to 2 till the last entry. So use the same shortcut key, that is a shift plus control plus downwards key. When you do that, it automatically select all the entries in this data, and when you go up you will get the all the entry data till 1737 cell. Then close this bracket and then press enter. So this is the mean of the population. Now we need to calculate the standard deviation. So standard deviation, there exists a inbuilt command for this one, that is the is equal to standard deviation STDEV dot. Now we have a two option, one is population and a sample. Since we are working with the population, therefore we are going to use the first command with P. Then open bracket. Again we need to select the data. So data is given in the column A. Select A2 cell. Then use the shortcut key, that is a shift plus control downward key, and then close this bracket. So you can observe over here. So once you close this bracket and then press enter. So with this you will get the standard deviation of the population. Next, we are going to find the normal distribution for this intervals given in a column D, so in which we have taken the 0.5 step size. So for that, we need to apply the concept of approximation. In this case, you can observe that 2 lies in the interval of 2 minus 0.25 to 2 plus 0.25, because the length of this interval is 0.5. So if you want to find the probability at x is equal to 2, so that is approximately calculated as probability of the random variable from 2 minus 0.25 to 2 plus 0.25. So that is equal to probability of x less than equal to 2 plus 0.25 minus probability of the random variable less than equal to 2 minus 0.25. Now use this concept in Excel. For that, select an empty cell, suppose G2. Now we are going to use the inbuilt command for the normal distribution, that is the Norm.dist. In order to apply that command, write is equal to norm.dist. Now open bracket. So it indicates it requires the four things. One is x, that is your random variable. Then mean, standard deviation. After that, if it is a cumulative, we will write true, otherwise false. For x, we will input the interval range, and that is given in a column D, means x is given in a column D. But in order to evaluate the probability for x is equal to 2, we need to use that concept of interval. That means we will use plus 0.25 over here, and after that we will take the same command, and in place of writing plus 0.25 we will write minus of 0.25, followed by the comma. Write the value of mean. Mean is given in a I2 cell, followed by the comma. Now we need the standard deviation, that is given in a I3 cell, comma. Now we need to find the cumulative or a probability mass function. Right now we are working with the cumulative distribution function. Therefore, we will write true. So before pressing enter, make sure we need to lock the I2 and I3 cell, that is defined as a mean and the standard deviation respectively. So we will click in between I and 2 and then write dollar, and same for the dollar in between I3 to log the cell of mean and standard deviation. Then close this bracket, minus. Now we will take the same distribution, and in place of plus we will write the minus. So write norm.dist, open bracket, Select D2 again, minus 0.25. Then mean is given in a I2 cell, I$2 to fix the cell, followed by comma, I$3 that fix the standard deviation cell, followed by the true in order to calculate the cumulative distribution function, and then close this bracket. Now press enter to get the probability corresponding to this interval. Similarly, we will calculate the probability for the rest of the values of bins. For that, select G2 cell and move your cursor to the right bottom corner until it turns into the plus sign. Then drag this out till G18. So once you do that, you will get the probability distribution, that is the cumulative probability distribution corresponding to the column D, where it represents the interval form from particular number plus minus 0.25. Now in G1 cell you can write it is a normal distribution. So n of the random variable with mean followed by the standard deviation. Next, we can visualize this evaluated distribution using the chart. So for that, first hide the E cell because we need the chart for the D, F and G cell. So for that, click on E cell, then click on a right, then click hide. Next, we need to select the data from the D, F and G cell. So you can select this data. After that, click on Shift plus Control and down key to get select the data from these columns. Then move to the Insert tab, go to the recommended chart. So from here you can choose any chart to observe the behavior between the fx and the normal distribution. So suppose you are selecting the line chart, then press OK. So once you do that, from here you can check it. The orange line is for the first series, that is your fx, and this gray color represents the normal distribution. So you are getting a normal curve over here as the bell shaped, and the gray line is the approximation for the probability fx. Also, you can choose any other recommended chart to observe the behavior. One is a line chart, another can be cluster columns. From here you can see that you are getting a well-shaped curve from this approximation.